Using hardware interfaces with Python requires specific binary libraries. Thus, it is not as easily exchangeable among platforms as the hardware-aware parts of the Python code. In those examples, we present how to interact with hardware using GPIO, which is a basic interface for interfacing with other devices, such as sensors and actuators. Examples are given for the RPI with Python and for MicroPython installed on RP2040. Below is the sample code for changing the state of the LED on GPIO 16. Note the use of RPI GPIO library. An equivalent solution for the MicroPython on RP2040 MCU is presented below. Note the use of the machine library instead of RPI GPIO. Similarly to the GPIO, interrupts are hardware specific. Thus, libraries may differ among platforms, hence Python syntax. A code represents an example application that switches the LED on and off when a button is pressed. The LED is connected to GPIO 16 and the button is connected to GPIO 17. A similar code for MicroPython running on RP2040 is presented. Note the behavior of the Read-Eval-Print Loop (REPL) mechanism for the RP2040 when writing code in line. Write to the Python prompt. The code in the version that uses timers to flash the LED. And similarly, the interrupts to handle the button does not need a dummy loop by the end. The timers and the interrupts started inline are continuously running in the background. That is, not the case when the file is run as a whole. You need a block loop to ensure the execution does not quit unless expected, e.g., using a keystroke.